Hello students, after a very long break due to the examinations, now we are meeting. Nice, and we have some subjects or some topics left in our fourth lesson, work, energy and power, and this is going to be the session number 4, and today we are going to see a single but very important topic, which is motion in a vertical circle. Shall we go to the motion in a vertical circle? What do you mean by this motion and all these vertical circles? See, imagine that a body of mass m which is attached to one end of a massless and inextensible. That means you cannot extend that string to a next level, like a string with which is made in a iron or steel. So inextensible string executes circular motion in a vertical plane with the other end of the string is fixed. Now the length of the string becomes the radius of the circular path. The motion of the body by taking the free body diagram FBD at a position. Here the position vector R vector makes an angle theta with the vertically downward direction and the instantaneous velocity is as shown. We can see the instantaneous velocity as the two forces acting on the mass. Already I told you the mass is m. Now the gravitational force which acts downward and the tension along the string up. You can see all these things in this picture. See, if you have rotate a string with in your hand, you will get a angle, and that angle is mg sin theta, and which is equal to mass into acceleration of 1. So mg sin theta is equal to, here the acceleration is equal to dv by dt. As you know, it is velocity with respect to the time. So dv by dt, but it's in a negative angle. Why it is negative? It's because the acceleration is in a tangential retardation. Here it is in a tangential retardation. That's why we get a negative symbol here. So substituting the value of a1 in this equation 1, we get minus m dv by dt. See, this is the rotation of the vertical motion of a body in a vertical circle. In the radial direction, that means in the radial direction, this T minus mg cos theta. Here T referred to the tension of the string, and mg cos theta is in the radial direction. You get m is equal to m into a1. Here a1 is equal to dv by dt, or you can put minus t minus mg cos theta is equal to mv square by r. Let us have this as the equation number 2. a1 is equal to v square by r, which is the centripetal acceleration. In last classes, few more classes before, we got the equation of centripetal acceleration. I think you remember that. So we put a1 is equal to v square by r. Using all these things, the 4 important facts to be understood from 2 equations are as follows. The 2 equations which we have are, one is mg sin theta is equal to minus m dv by dt, which is the equation number 1, and t minus mg cos theta is equal to mv square by r, which is the equation number 2. Using that two equations, now we get some important facts that are: first one, the mass is having tangential acceleration, that is g sin theta for all the values of theta except theta is equal to 0 degree, and it is clear that this vertical circular motion is not a uniform circular motion. Second important fact, from the relations 1 and 2, as I mentioned earlier, we get, it is understood that the magnitude of velocity is not a constant in the course of motion. That means it can have the minus a1 and plus a1. So it has been different in two different situations. Therefore, the tension in the string is also not constant. Third important fact is the equation 2. The equation 2 means t minus mg cos theta is equal to mv square by r highlights that in the section A and D of the circle, for minus pi by 2 is less than theta, which is less than pi by 2, therefore cos theta is positive. The term mg cos theta is always greater than the 0. Hence, the tension cannot vanish even when the velocity vanishes. The fourth equation, the equation 2, again I repeat that equation, t minus mg cos theta is equal to mv square by r, which is equal to, further highlights that in the section B and C of the circle, for pi by 2, which is less than theta less than 3 pi by 2, cos theta is negative. The second term is always greater than 0. Hence, velocity cannot vanish even when the tension vanishes. You can see this V2 and V1 in the picture. Here this is the ball or a mass, and or this is the body 1 and this is the position 2, which is V1, and here it got V2. These points are to keep in mind while solving problems related to motion in vertical circle. Students, remember, we are going to have a lot of problems using this motion in a vertical circle. So the direction of velocity is tangential to the circular path at all the points. Let t vector 1 be the tension in the string at the lowest point here, and t2 be the tension at the highest point, and t be the tension at any other point. That means between this 1 and 2, between this 2 and 1. Tension at each point acts towards the center. Okay. The tensions and velocities at these points cannot be found by applying the law of conservation of energy. Now, the first lowest point in the circle. When the body is at the lowest point 1, the gravitational force mg vector, which acts on the body, which is vertically downwards, and another one is the tension T1 acting vertically upwards, that is towards the center. From the equation 2, we get T1 minus mg is equal to mv1 square by r. Let's have this as equation number 3, and T1 is equal to mv1 square divided by r plus mg. We take mg in the right hand side. While it's moving to the right hand side, we will lose the negative symbol. For the highest point 2, at the point 2, both the gravitational force mg on the body and the tension 2 acts downwards, that is towards the center again. So T2 plus mg is equal to mv square, and which is divided by r. Therefore T2 is equal to mv2 square divided by r minus mg. We take this plus mg here, and so we put a negative symbol. Let's take this 2 as equation number 5 and 6. From equation 4 and 6, it is understood that T1 is greater than T2. The difference in tension T1 minus T2 is obtained by subtracting the equation 6 from the equation number 4. So we get T1 minus T2 is equal to mv1 square by 2 by r plus mg minus mv2 square divided by r minus mg. Therefore T1 minus T2 is equal to m by r. We take it as common. So v1 square minus v2 square plus 2mg. The term v1 square minus v2 square can be found easily by applying the law of conservation of energy at the point 1 and also at the point 2. See, the tension will not be at any work on the mass, as the tension and the direction of motion is always perpendicular. Remember, the gravitational force is doing the work on the mass. As it the conservative force, the total energy of the mass is conserved throughout the motion in the circle. So the total energy at a point 1 E1 is same as the total energy at the point 2, which is E2. Therefore we get E1 is equal to E2. Potential energy at a point 1, that means U1 is equal to 0, and by taking reference as a point 1, we have or we received the kinetic energy at the point 1 KE1 is equal to 1 by 2 mv1 square. Now the total energy at a point 1, that is E1, is equal to U1 plus KE1, which is equal to 0 plus 1 by 2 m1 v1 square. Because the potential energy is 0, we have only the value of kinetic energy. The kinetic energy value is 1 by 2 mv1 square, and which is the total, the final energy at the point 1 is 1 by 2 mv1 square. Similarly, the potential energy at point 2 U2 is equal to mg into 2r, because h is 2r from the point 1. That means the height of the body which is at the position 2. So kinetic energy at the point 2 KE2 is equal to 1 by 2 mv1 square, and the total energy at the point 2 E2 is equal to U2 plus KE2. Therefore 2 mgr plus 1 by 2 mv2 square. From the law of conservation of energy, which is given in the equation 7, we get 1 by 2 mv1 square is equal to 2 mgr plus 1 by 2 mv2 square. After rearranging this, we get 1 by 2 m v1 square minus v2 square, which is equal to 2 mgr. While taking this 2 in the right hand side, we have, and we cancel this m and this left hand side m and right hand side m, we get v1 square minus v2 square is equal to 4gr. Let us consider this as equation number 8. And substituting the equation 8 in the equation 6, we get T1 minus T2 is equal to m by r 4gr plus 2 mg. Therefore, the difference in tension is T1 minus T2 is equal to 6 mg, because we cancel this r and here r. So we get 4 mg and 2 mg, therefore it is 6 mg. Let us consider this as equation number 9. Minimum speed at the highest point 2. The body must have a minimum speed at point 2, otherwise the striking will slack before reaching point 2 and the body will not loop the circle. To find minimum speed, let us take the tension T2 is equal to 0 in the equation number 6. Okay, that means the equation number 6 is T2 is equal to mv2 square divided by r minus mg. So 0 is equal to mv2 square divided by r minus mg. mv2 square by r is equal to mg, and while taking this, here you can cancel this m and m. So v2 square by r is equal to g, or v2 square is equal to rg. You can take this r into the right hand side. So finally we get, taking the square root in the right hand side, v2 is equal to root of gr. This is the equation number 10. The body must have a speed at a point 2, that means v2 is equal to root of gr to stay in the circular path. Now let's move to the final position, that means minimum speed at the lowest point 1. To have this minimum speed, we have v2 is equal to root of gr at the point 2. The body must have minimum speed also at the point 1. Now by making the use of the equation number 8, we can find the minimum speed at the point 1. That is, the equation number 8 is v1 square is equal minus v2 square is equal to 4gr. Substituting the equation number 10 in equation number 11, we get v1 square, which is equal to v1 square minus gr is equal to 4gr, because the equation number 10 we get v2 is equal to gr and root square of v2 is equal to gr. That's why we put gr here instead of this. While substituting this, you can take this gr into the right hand side. Therefore v1 square is equal to 5gr and v1 is equal to root of gr. Remember, the body must have a speed at a point 1, v1 is equal to root of 5gr to stay in the circular path. From equations 10 and 11, it is clear that the minimum speed at the lowest point 1 should be root of 5 times more than the minimum speed at the highest point 2. So the body loops without leaving the circle. Thank you students, study well.